Alright, and so let's show this here. Um, just had shown the display there in the other video. Kind of reworking it here. Same kind of basic design. I only have one layer here, as I really only need to work with one layer to test out the logic before replicating it across. But basically, what I'm trying to show here is that we're just introducing a signal here right internally to this whole thing, and then making sure that this stays locked. Basically, this is kind of more similar to a first design concept that I had, um, where I had basically the ability to not only like let a signal in, but also to nullify it, but also includes a like a NOT gate, and so basically it passes one version of the signal in, but I also am working with like doing like so inverting the signal as well as passing a signal straight in, but I haven't quite got that all working, as you could probably tell here. There's some disconnected stuff. Unfortunately, yeah, there's a few things that need to happen, and I haven't quite all got it all working. Using this is what's called a multiplexer here. Using the an add-on mod that I have. Basically, I have some extra components here that I've been testing out, but didn't quite get finished with it. So unfortunately, that wasn't really complete. Let's also go over here. Maybe I could show off one of these. These were more the early design, and this is specifically, let's see if, yeah, this was really early design. I was passing up a staircase here. I don't really even, I don't think that even worked. Let's go over here. Sorry, I'm just kind of equating myself with the actual designs that I had, but from these were from quite a while ago. But this was the original memory cell here, and so basically, as I was explaining it to someone here, basically what this does is locks a signal in place. If once this turns off, it lets a signal lock in. So usually what you do is place a signal on here. This would be the read line, right? So if you wanted to, thing here, if you wanted to send data in, you would set it on this line. Now notice it doesn't lock in place because this is already locked. So a signal can't get into it. So essentially you can't write that until this pulse is 0. The only way this will turn off is if you say, okay, I want to commit specifically to this. Let's turn all these off since it should be set to 0. So I turn all these off, and it should allow a signal in as well as out, and it does. Notice that lock went off. So now if I want to go ahead and lock a signal in place, I can do that. Now let me see if I remember. Yeah, see, this also didn't have any of the control lines, so unfortunately this is just addressing. As I discovered later, you need to actually have control logic as well to lock the signal in only when you send the control logic to do so, or basically commit a write. Let me see if I can find that. And I think, yes, this over here had all that. So this is the actual, this right here is the one that has everything. So, okay, boom. Now, with this, you'll be able to see, this is, let's just say I want to commit a write in here, right? So let's just write it, say we want to write a 0, okay? Well, 1 is locked in, you can see that because it's already set right there. But if I want to lock a 0 in place, I can do that by saying, okay, depending on which way these are going, data is going in that way, so this should be cell 0. So let's just set all of the address bits to 0, and there's really only one layer of addressing, so we can only address, say, 4 bytes, I guess, or something. Anyways, assuming these are all correct, and we want to write, now we should be able to do that with a write byte over here, and then boom, we set that, and what that should allow us to do is write onto that. So now notice how 0 gets, that unlocks, and now 0 is on there. Now notice how these are all locked, right? So that's because the only one that's addressed is 0, 0. And if we want to say address 01, we can do that too. Now let's go ahead and turn this off, and what will happen is now 0 will lock in place. See how that's locked again? And 0 is now there. So 0 is now locked in, and if we try to write over it, we can't because it's locked. So that's how memory works basically right there. Now notice nothing comes out here, right? 0 is locked in place, but 0 isn't being fed out here because of this side right here. But if we wanted to read that, we could do so by setting a 0 over here. So if we set a 0 on this line, let's just go ahead and break that connection. I believe it'll allow, notice how that went off. So now 0 can come out here. Now, likewise, if we want to go ahead and write a 1, notice how we can't write it and it can't come out, right? But if we want to allow a write, we go ahead and we set this line, boom. Now it commits the write. Well, should turn it off. Maybe this has to be on. I forget. Basically, boom. Probably allows the write. And then, yeah, notice, boom. Now it allows the write. And we want to lock it in place. So what we do is now turn this off and turn that off. Well, we'll just leave that. It doesn't really matter. And it'll get through. And notice, it won't get through because this is still on. So this is like a clock signal, and it only allows read or write depending on what the signal is over here. And then boom, now it gets through. So yeah, that's basically how memory works. And so now you can see the whole working thing. And it's really cool because I can address any one of these. So you'll notice that the signal is carried across the whole line, and that's why really the addressing is so important. So that notice that one gets through on that one because it was addressed, but it doesn't get through on any of the other ones. So yeah, that's exactly how my computer will work and how memory will work on it. And it's a very, very cool design when you think about it. But yeah, it's that's all this passes the data in. So each one of these is a bit, and then you have 8 bytes, right? 8 levels that carries 8 bytes. And right here is the control. Sorry, I'm dropping stuff here. But this is the addressing layer right down here, which tells it which address, and you set the the bits on the 2 address lines on either side. And then this is the control layer right here that you send the signals in to commit a write to the cell or to read the output on this end based on the control logic put in here. So if the cell is addressed and the logic passes on this side, then it will allow that data to come out on this line right here. So that's how that works. Pretty cool, huh?